All right, 2.1, algebraic and graphical solutions to linear equations. What's a linear equation that we usually keep the form of that we like to see the equations written in? What form? Y equals mx plus b. That's called the slope-intercept form. And so we're going to do some solving of those algebraic solutions, equations. And they have special names, which you see in bullet 2, solution, zeros, and x-intercepts. And then we'll show you the graphical solution. That's all we're going to do in 2.1 today. All right, so let's start with this first one. Thank you, ma'am. This next slide doesn't say anything it's just saying that use for finding exact solutions. When we want an exact solution, which you will see on the screen in the homework, it's going to say something like, I want the exact solution. So, for example, if an answer turns out to be 5/7, and let's say the answer for 5/7, you don't have to write this down, I just kind of want you to understand. The answer for 5/7 might be 0.7986, that's not 67112, and it might go on. You see what I'm saying? The exact answer is 5/7. I'm not going to be able to write all of those numbers because they don't stop. So if you stop it, is that the exact answer if I stop it right here? No, that's just an estimation or an approximation. So the exact answer is this one. The approximation is this one because I just cut it off at whatever number I chose to round it to. You understand what I'm saying? So if it says it wants the exact number, they do not want you to round it. They want you to leave it just like it is as long as it's simplified. If you get something that has a square root in it, like this, they do not want you to put this in the calculator because this comes out to be 1.4141 something, something, something. So what's the exact answer? The square root of 2. What's the approximation? 1.41 something, 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 something. So again, just reminding you is that when you get to these, some of them are going to ask you for an exact solution, and some of them may ask you to round. So this is exact, this is rounded. Just know what they want when they ask you for it. Alrighty, so with that said, here is the first equation that we are going to solve. Whenever you see the word solve, it means get the variable, whatever variable they're using in that particular equation, by itself. In this particular case, what variable are we using? We're using x. So the goal is to find the solution. Solve means find the solution. The solution for what? The solution for x. What number, what they're asking you to do for number 1 here, what number can you plug in for x over here and for x over here on the right that's going to make the right side and the left side equal to each other? You see what I'm saying? What number can be plugged in for x on both sides of the equal sign that's going to make the right side equal to the left side? Well, we could trial and error and start plugging numbers in, but that's not the way we want to solve it. We could be all day plugging numbers in to figure out which one is the right answer. So we're going to actually solve it and get x by itself. All right, so let's write on the board so you can figure out what you got to do. You'll have homework problems like these as well. So here we go. I've got 5x minus 14 on the left side of the equation and 23 plus 7x on the right. The goal is to solve and get x by itself. I usually like to move my x's to the left, but do you have to? No. As long as x is by itself, it can be on the left or the right, as long as it's by itself. Standardly, I like to keep it on the left. You don't have to. If I decide to keep all the x's on the left, guess what I'm going to do first? I'm going to subtract 7x from both sides. Why? Because I want my x to stay on the left side. I want my variable x to stay on the left side. So with that said, I am going to now simplify. So I've got 5x minus 7x. How much is that? Negative 2x. So over here on the left, I've got negative 2x. Bring everything else down. So minus 14 is going to come down. The equal sign comes down. The 23 comes down. What happens to the 7x and the minus 7x? That cancels out. So that's gone. What's our goal again? To get x by itself. What should I do now to get x by itself? Add what? Add 14 to both sides. What you do on the one side, you got to do on the other side of the equal sign. Alrighty. So I'm just adding or subtracting vertically up and down. So negative 2, we don't have anything to add to negative 2. What about my negative 14 and my positive 14? They cancel out because that's 0. 23 plus 14 is how much? 37. All righty. Almost done. What should I do to both sides? I've got a negative 2x equals 37. Divide both sides by negative 2. So here we go. The negative 2's now cancel, and I have x is equal to negative 37 over 2. Is that the exact answer or an approximation? That's the exact answer, and that's the answer that they want in the homework. That's the answer that they want in the homework. It may look like a weird answer, but that's the answer that they want in the homework. What were we solving for? X. Does it have to be an X? No, it does not. It could be whatever letter of the alphabet they choose as the variable. Alrighty? How does that one feel? You were comfortable? That was okay? Okay. Here is the second equation. What's the difference between the first equation and the second equation? Just fractions. You just got fractions in them. So are we going to kind of follow the same process? Yes, only we're going to do something to get rid of the fractions first, because you didn't really want to play with them fractions, did you? Okay, so let's work on getting rid of the fractions first so we can go back and do what we did with the first problem. Alrighty, so let's write this one. Let me write this one down so we can start our steps. That's 2/3 x minus 6 over 5 equals 1/2 plus 5 over 6 times x. Alrighty, we need something called a least common denominator. We need the number, a least common denominator is the smallest number that you can divide 3, 5, 2, and 6 into. Okay? How do you find that number? Well, let me show you. How many of you remember how to do least common denominator? Here's how we find the least common denominator of these numbers. Usually, I just start multiplying. Find LCD. This is just means find LCD. Start multiplying. Alrighty. What's 3 times 5? 15. Alrighty. Does 3 go into 15? Does 5 go into 15? Does 2 go into 15? Ah, that doesn't work. So we can't use 15. Keep multiplying. So now I multiplied 3 times 5. Now I'm going to multiply 3 times 5 times 2. What's my next denominator? 2. Multiply times 2. So I'll leave this one up here. We're going to 3 times 5 times 2. How much is that? We said 3 times 5 was 15. 15 times 2 is 30. All right, let's go back and ask ourselves the question again. Does 3 go into 30? Does 5 go into 30? Does 2 go into 30? Does 6 go into 30? Done. That's your LCD. So we stopped here because all of those numbers divide into 30 evenly. Multiply together the bottom numbers until each one of those numbers divide into that number evenly. So this one doesn't work. Alrighty, so now that you know the LCD, and I'm showing you this a different way, this is probably not the way you were taught to actually simplify this equation. I'm going to show you a different method. Most of the times they tell you to take the LCD that we just found and multiply everything on both sides by that 30. That's usually what you're taught, perfectly legal, and if you're comfortable with it and that's what you're used to, go ahead and do that. That's okay, because I don't want you to be confused from what you're used to doing. My goal is I don't want to see the denominators, so I want to get rid of them. Turn all of your denominators into 30. Here's what we're getting ready to do. I want to multiply each one of these denominators by whatever I need to multiply them by so that they become 30. Do you understand what I'm asking you to do? Turn them all into 30. So, first question I want to ask you, what do I need to multiply 3 by to turn it into a 30? What you do on the bottom, you got to do on the top. All righty. What you got to multiply 5 by to get 30? Multiply the bottom by 6, multiply the top by 6. What do you got to multiply 2 by to get 30? 15, so multiply divided by 30. Does it matter whether I put this 15 in the front or the back? No, you can put it in the front or back. It doesn't matter whether you multiply it in the front or the back, as long as you do it on top and bottom. And then the last one, what do you multiply 6 by to get 30? 5. Let me leave my X here. And so I'm going to put a 5 here and a 5 up here. Now, what are the bottoms of your numbers, or what are your denominators now?
30.
All of them are 30. Once they're all 30, you don't need them anymore. You can delete them. What's left is what you want to work with. Now that they're all become 30, you don't need them anymore. You can delete them. So then I only want to work with what's on top. Tell me what's left on top now. 10 times 2 is 20x. And 6 times 6 is? And 15 times 1? And 5 times 5? 25x. All righty. Now, do we now have an equation that looks like the first problem we did? Well, did you want to keep playing with those fractions?
No.
Now, it's up to you whether you like this method or whether you want to go back and do what you're used to doing. Did it make sense to do it this way?
Yeah.
Okay. Now we're just going to work with it and get x by itself on whichever side you want to do it. I'm going to get x by itself on the left side again. So that means I'm going to subtract 25x from both sides. You could have done it the other way and subtract 20 from both sides. Perfectly legal. If I subtract 25x from both sides, I'm going to have a negative 5x over here on the left. Bring down your minus 36 equals 15, and my 25 and minus 25x cancels out. I'm now going to do what to both sides? Add what? Add 36 to both sides. So you end up with a negative 5x, the 36 and the positive 36 and negative 36 cancels. And you end up with 15 plus 36 on the right, which is at 51. 51. Divide both sides by? Divide both sides by negative 5. And my answer is what? What's my solution? We call this the solution. My solution is negative 51 over 5. Done. Questions? Okay, can you do this by yourself? With practice? With practice, okay. I'm just trying to make sure you're okay. The next slide, we're going to talk about what these answers we just figured out are called. Ready? Here's the next slide. Solutions, zeros, and X-intercepts. The X-intercepts are what again? Because we've talked about X-intercepts before. What are the X-intercepts? Where the graph crosses the Y or X? X. If it's an X-intercept, it's got to cross the X-axis. If it's a Y-intercept, it's got to cross the Y. So these are, for X-intercepts, it's the point where it crosses the X-axis. Their names are also called real zeros, and you can rewrite it in the form of a function. So that last bullet said real solutions to an equation of a function. So here's what I'm saying to you for the first bullet. The first bullet just says you're just going to have some points on a graph and they're going to cross or touch the x-axis. That's all the first bullet says. The second one says they're called real zeros. Where it crosses the x-axis are called real zeros. You're like, well, why do you call them zeros? Let me ask you a question. If I have a graph here, and I have a point here, and I have a point here, over here, there's my point, and right here is my point. Are these points on the x-axis? Are they x-intercepts? Yes. All right, so my x-intercepts are -3 and 4. How do I write them as an ordered pair? -3, 0. And this one, the 4, 4, 0. They call them zeros because the last number is a 0. So if they say, what's the zeros? You're going to give them these. They're the same thing. X-intercepts and zeros are the same. It doesn't mean the number 0. It's just calling these things zeros now. So when they say, what are the real zeros? They want to know -3 and 4, which is the same thing as X-intercepts. So again, X-intercepts and real zeros are the exact same thing. Just like, remember I told you slope and rate of change are the same thing? Two phrases mean the exact same thing. Real zeros and X-intercepts are the exact same thing. Okay? It's where the function equals 0. So let me look at that last bullet for it again, because I want to make sure you understand the last bullet. You see where it says it's where f of x is equal to 0? What's the f of x refer to again that we learned back a few slides back? Is the same thing as y? Yeah. So it says it's where y is equal to 0. Well, isn't y over here equal to 0? Yeah. It's always where y is equal to 0. So that's why they're just saying it's where f of x is equal to 0. The y value will always be 0 for that point. And those are x-intercepts, so the y's are always going to be zeros. You okay? Y'all look like I got to process that. Alrighty, so let me let that sink in for a second, and let's do something so you can figure this out. So let's apply it to an actual math equation or function so you can see what this really means. All right, so for each of the functions you see below, we want to find the 0 of the function. That's why I said 0 and intercepts are the same thing. So when they say find the 0, they want you to find the x-intercept. This one says find the 0. Notice bullet 2 says find the intercepts. They're asking you to do the same thing because they want you to get to the point where you're comfortable with understanding zeros and x-intercepts are the same thing. So if I say, what's the x-intercept? And you say 3 or -3. And I say, what's the 0? You say -3. So they're going to ask you the question twice just to make sure you understand what it is. And still, that last bullet says it's where the y is equal to 0. So let's see if we can work this problem out and make it make a little bit more sense. First function that you see on the board, what is it and what does it say? F of x is what? Okay, so f of x is equal to 6x minus 120. They want us to find the zeros, or I could say find the x-intercepts. So here, you want to find the zeros or the x-intercepts, because they mean the same thing. Set the equation equal to 0. To find the zeros or x-intercept, set the equation equal to 0. Then get x by itself. Okay? Alrighty, so I'm going to set this equation equal to 0. 6x minus 120 equals 0. Solve and get x by itself. What should I do now? Add 120 to both sides. The negative 120 and the positive 120 are going to cancel out because they become 0. You're left on the left side with 6x. On the right side, you got 0 plus 120, which is 120. What do I do next? Divide both sides by how much? 6. By 6. So the solution is how much? 120 divided by 6 is? 20. So what is this answer called again? You got 3 names for this answer. It's called the solution. It's called the x-intercept. And what else is it called? The 0. Those are the 3 names for that same answer that you just got. X equals 20 is the solution, the x-intercept, and the 0. All 3 mean the same thing. So we're just saying x equals 20 is all of these. So, on any test that you would get, if I give you a function or an equation like that and I say find a zero, what you gonna do? You're gonna do exactly what I showed you. Now, on every single test that I give, there's a problem like this one. And I say find a zero. Tell me what some of y'all gonna do. If I say find a zero, you should set it equal to zero. But what might you do just accidentally? Plug a zero in for the x. You do not plug a zero in for the x. You set the whole equation equal to zero and solve for x. Okay? All right, well, let's work on this next one. Here's the next one. I've got f of x is equal to 330 plus 40x. What am I supposed to do if I want to find the solution, the x-intercept, and the zero? Set it equal to zero. Okay. Set the equation equal to zero. And solve and get what? Get x by itself. So I'm going to minus 330 from both sides. Did I put the wrong number? I sure did. Just supposed to be a zero. Set it equal to just zero. Nothing but zero. Okay, so I'm going to minus 330 from both sides. So the 330 and the negative 330 on the left side cancels out. So I'm left with 40 equals negative 330. Divide both sides by what? All right, so now once we divide both sides by 40, we get negative 330 divided by 40. Is that my final answer? No. No. What can I divide both top and bottom by? I want to simplify this fraction. What's the biggest number that I can divide both into? 330 and 40. I heard it, I thought. 10. That's your GCF, your greatest common factor. So divide top and bottom by 10. So that means x is equal to negative 33 over 4. Is that the exact answer or an approximation? That's the exact answer. If we divided it and the calculator gave us a decimal, it would be an approximation. Okay, questions?
So when it's set like that, we have to find the greatest common factor?
If you have a fraction that's not reduced. Anytime you have a fraction that's not in the simplest form, you have to find the greatest common factor that you can divide out of top and bottom. Yes.
So the whole fraction is going to be negative, right?
Mm-hmm.
Because in the homework, it's real sensitive.
It is.
Like if you,
It is. It is sensitive. The homework is sensitive. I will say that is true. It could be as simple as, you know you got a zero there, but you accidentally hit the O instead of the zero. Or it could be you making sure you put the right character in, or you got the right number of commas in between your answers. You know, it's just as simple as, it literally can be. Usually, like I said, if the answer is a negative something, I will always put the negative in the middle. I don't put it up top or bottom. I always put the negative in the middle, then I hit my little fraction symbol at the bottom of the page. You know, when you see your little fraction symbol at the bottom of the My Math Lab page, it'll have a set of boxes and it'll have a box that looks like this. So I'll click negative first, I'll put my negative, then I'll hit this box and let me put something in the top and bottom, but I'll always put the negative in the middle. What you thinking?
I know, because last night I kept in the negative up top.
And I'm not saying it'll mark it wrong, I'm just saying for me to be on the safe side, I'll just put it in the middle. Did yours mark it wrong because you had it up top?
But I kind of figured out, can you get 3 tries?
Yeah.
So I kind of figured out the third one.
Okay, but was it because you had the negative up top, or it needed to be in the middle?
It needed to be in the middle.
Okay. All right, y'all heard that. It needed to be in the middle. Now, it's sensitive to the equations in terms of if they use X and Y's, you got to use X and Y's. If they use T's and P's, you got to use T's and P's. So just kind of make sure you're looking at what variables they ask you to use as well. Yes, ma'am.
How do you get negative 33 over 4?
So when you divide, literally, and I do want you to use your calculators, when you divide 10 into 330, you should get 33. Is that what you got?
Yeah.
Okay. And if you divide 10 into 40, did you get 4? Okay. So are you wondering where I got the negative sign from?
Yeah.
You only got one negative. A negative divided by a positive is a negative.
Oh, okay, so I should have put the negative in the front.
See, originally, the negative is on that negative 330. So I just kept bringing the negative down, the negative down.
Oh, okay.
When I simplify the final answer, there's only one negative sign. It goes in the middle. That's what I'm saying. When I simplify my final answer, I want my negative sign in the middle. But it did start out as being up top. Do you understand why the negative sign can start out up top? So if I work a problem out and I get to the end of the problem and this is what it looks like, that's the right answer. When I type it into my math lab, I'm going to retype it with that negative in the middle. If there's one negative sign in a fraction, whether it's up top or on the bottom, you put it in the middle. If there's two negative signs, they're going to cancel each other out and become positive, right? But if there's one, put it in the middle. Yes?
On the test, are you going to require us to like write out how we got the greatest common factor, or could we just do it on our calculator?
You can just do it on your calculator. It's up to you whether you want to say that or not. So this part right here, that's what she's asking me. Do I need to show this on my paper? No, it's up to you. I can see where you went. So if you went here and you got that answer, I know you divided by 10 on both sides. If you got a different answer, then somewhere something went left. Okay? All righty, so let's see what the next slide says. Utilize the X-Intercept to find the solution to the function f of x equals 0. Okay, this is for graphing. So we're going to go to the graphing tool and see if we can do this using the graphical method. So the next slide is going to take us to Desmos. Ready? I need you to go to Desmos and type that in for me, please. Go to Desmos and type that equation just like you see it. You've got 3x minus 8 equals 15x plus 4. Let me know when you're done. Three x minus 8 equals 15x plus 4. Did you get a picture of a graph? No, you didn't. What did you get? You did get a straight line. What else did you get? Is that it? Let me type it in and see what I get. 3x minus 8, 15, 4. 3x minus 8. That's not what I want to do. Okay. What's the answer? Okay, so when I say what's the answer, I'm asking you what's the solution? What's the 0? What's the x-intercept? What's the x-intercept again? Where it touches the x-axis. Did it touch the x-axis?
Yes.
Did it touch the x? Look at the x-axis. Is the x-axis this line horizontal all the way across here? When I say did it touch the x-axis, we want to know, did the purple line touch the x-axis?
Yes.
Where?
At the -1.
At -1. Every time they ask you for a 0, will the second number in the order pair be a 0? Yes, it is. So I want the first number because I already know the second number is going to be a 0. So what's the solution? -1. What's the x-intercept? What's the 0? Thank you.
The 0 is -1?
Mm-hmm.
Because it's over on the negative side.
The 0 is -1 because the second number in that order pair is 0. Remember, 0 is the same thing as the x-intercept. They're just calling it that. What is the 0? They're just saying, where is it that it crosses the x-axis? At what point? -1, comma 0. That's your 0. I know it sounds weird to call it a 0. It really does. But that's what we're calling it in the math information. So, with that said, so in any of these, could you just type these in Desmos and it's going to give me a line crossing where it crosses the x-axis? In every single one. Now, the only thing with my math lab, it's not gonna give you it's not gonna give you a fraction. It'll always give you a decimal. So we couldn't have used decimals for this one, nor this one, nor this one. Meaning you could have used it, but it's gonna give you a fraction. But the homework is gonna say, I want the exact answer. And if they say they want the exact answer, you need the fraction, not the approximation, which is what Desmos is going to give you. So again, if we type this in here, I just want to put this other one in here so you can see 5x minus 14, and you can type it so you can see it for yourself. The first one we did was 5x minus 14 equals 23, 23 plus 7x. Okay? I'll make my screen smaller so I can see. What answer did we get? So that's going to be where did my line go? Oh, there it is. You see your black line? I had to change my screen so I could, or shrink my screen a little bit so I could see it. Yours might not be black. Your line might be blue, purple, green, yellow, orange. It doesn't matter. The first line we did was purple. And so if I actually show where it crosses the x-axis, where does it cross the x-axis at? Negative 18.5. That's the same thing as negative 37/2. Now that is an exact answer just because the decimals don't go on and on and on and on and on forever. But I'm just telling you this to say the homework wants negative 37/2. Okay? We got it? So this is how you find the graphical solution to these problems. So in the homework, some of them are going to strictly ask you for the graphical solution. Some of them want the exact solution. If they say exact, they want you to work it out by hand, algebraically. Questions? All right. No questions? All right, back to the PowerPoint. Let's see what we have next on the PowerPoint for chapter 2.1. Here is our next problem. So let's see how this relates back to real life. We always go back to real life with everything that you do in class. I have to show you how it connects back to something that you could have a concern about or a question about, or even something in society that makes sense. All right, always read the problem. The number of banks in the United States for selected years from 1980 to 2009 is given by the equation y equals negative 380.9 times x plus 18,483, where x is the number of years after 1980. Do we care about the banks before 1980? No. Okay? Now, let's read the question. If this model is accurate after if this model is accurate after 2009, in what year would the number of banks be 7,056? All right, so let's make sure we understand the problem and the question. What's the topic of conversation for this word problem? The number of banks after what? 1980. So when you start reading these, you immediately got to think something gets put in, an input and an output, or X and a Y, or T and whatever. What's the input? What's the output? Based upon what you read, what's the input? Number of what? Number of years. If you plug in a year, what should you get out? Number of what? If you plug in the number of years, you're going to get the number of years out? You're going to get the number of banks. So if I say in 1981 is my year, I should get number of banks for 1981, shouldn't I? Okay. If I say 1992, should I get a number of banks for 1992? Yes. So again, let's go back and do this. Can I erase what's on this board here? Okay. So if I erase here, always think there's going to be some input and some output. So you got to make sure you understand what's the input and the output every time you read a word problem. So here's my dryer again. Here's my dryer. I keep going back to my dryer concept again. Something goes in, something comes out. What's going in? X, but X represents the what? The years when? Okay, so what goes in is the number of years. When? After 1980. And what variable are we letting represent this? In this case, we're letting X. So X is going in, as the number of years. What's coming out?
Number of banks, the number, okay.
No, what's coming out is the number of banks. Okay, alrighty. And what variable are they letting represent the number of banks? Y. Okay, alrighty. And what's happening inside the dryer? Do you have an equation? Do you have to use it? Do you have to plug what's right here? What goes in, gotta go in, gotta get inputted or plugged into what? What does this X get plugged into? What does the value of the year get plugged into? Into the equation. So here is your equation. So what's happening inside of here? You gotta plug in a number into the equation. Alrighty? So once we plug it into the equation, we should get a number of banks out. Alrighty, so if this model is accurate after 2009, in what year would the number of banks be? 7,056. Now, I need to ask you a question. Every time they give you a word problem, either they're going to give you an input or output. A lot of times you're going to get an input and you just plug the input in and then tell me what the output is. In this particular case, what is the 7,056? Is that an input value or an output value? It's the number of banks. So that's over here. So they just told me the number of banks is 7,056 banks. That's all I know, that I got an output of that. What was the input? Tell me what the input was. Do we know what the input was?
No.
You do not. They didn't tell you. That's what they want you to find. It said in what year? That's the big question. What year was it this many banks? What year? So, do you have an equation to work with? Yes? So, again, let me go back over our steps to solving a word problem. What was our first step? Read the problem. All right, so let's just make sure we're following our steps and see what we got. All right, we read the problem, so that was step one. Read. We're good. Did we understand the problem?
Yes.
When I say understand, I just mean, do you know what every word in that word problem means? Do you understand what banks are? Do you understand how banks are used? Do you understand that there are so many banks every year? So I'm just trying to make sure you understand. So did you understand the basics of the problem? Okay, all righty. What was the next step we're supposed to do? Ask what's given. What do you know?
Equation 7,056 banks.
Okay, so you know back in the top part of the paragraph first, before you get to that 7,056, what did they give you? X is you got to define what everything was given. X is the number of years after what? Did they give you a Y? The Y is the number of what? Banks. Okay. Did they give you an equation? All right, you got an equation. And here's the equation. Y is equal to negative 380.9x plus 18,043. Is that it?
8.
Okay, alrighty. So you have an X value that you have an X variable that you know what it represents. You have a Y variable, you know what it represents, and you have the equation for the Y variable using the Y and the X. Alrighty. What did they give you in the question? Okay, so they also gave you a Y value equaling what? So we're going to say they gave you a Y value equaling 7,056 banks. All right, so this is all you got. So I'm just saying these are all the things that they gave you. What was step 4? What they want you to do? What you supposed to do? Plug in what? Plug in 7,056 for what? For Y. So let me say this before we say, let me, you can still write this, but I'm going to say this for you. you gotta find, what are you trying to find? Because you gotta know what you're trying to find before you knew to plug it in. What are they wanting you to find, the X value or Y value? They gave you the Y value, so what you gonna find? You gotta find the X value. Find an X value. Okay? And in order to do that, you have to now plug in the what that they gave you.
The Y.
You've got to plug in Y equals 756. Plug in Y. Plug in 7,056 for Y. And you're doing that for Y in the equation, right? Plug in that Y, plug in that 7,056 for Y in the equation. Alrighty, step 5 just said do the math. Alrighty, so now we go do the math. So in the place of that Y in the equation, what am I said I'm gonna replace that Y with? Okay, alright, so let's do what we think we need to do. So over here, I'm gonna erase this Y and put 7,056 in its place. Okay? So erase that. And in the place, I'm gonna put 7056 in that place. I did just what it said do. Now what should I do? What have we been doing before I got to this problem? What have we been doing this whole class? Solving to get what? X by itself, which is the solution, the X-intercept, and the 0. So we've been solving to get X by itself. What should I do now to get X by itself? Subtract what from both sides? Okay, so I'm going to subtract 18,483 from both sides. 18,483. Somebody do the math on the calculator. Tell me what that is. What is it again? So it should be a negative number. Negative 11,427. Okay, equals negative 380.9x. Divide both sides by? Okay, so here I'm going down on the next board because I'm running out of board space. Alrighty, so now negative 11,427 equals negative 380.9x. Divide both sides by that negative 380.9. These cross out, the negative 380 and the negative 380 cancel out. So x is equal to, somebody tell me what that math says.
30.
How much?
30.
Okay. Now I need you to tell me, did we answer the question? Say no. No. What did the question say? It wants me to find. In what year would the number of banks be that? What did you just find? You're almost there. What did you just find? You just found X, and what's X? What's the meaning of X? What do we define the meaning of X as? The number of years. Let me pull the board down so y'all can see it. All right, we said X is the number of years after when? 1980. So if that's the case, this ain't the final answer. This is just the number of years after 1980. So remember, right here, make yourself a reminder. This is the number of years after 1980. Well, how many years is that? What year is that?
2010.
How did you get that answer?
You just added 30 to 19.
So now you must add 1980 plus 30, which is 2010. So in what year were the banks 7,056? In the year 2010. When you answer a question, you should be able to, when you get the final answer, you should be able to read the question and restate your answer using the question. So if the question says, in what year would the number of banks be 7,056? You say, in the year 2010, the number of banks was 7,056. Do you understand what I mean when I say you can restate your answer using the question that they asked you? If you can restate it and answer properly, you're good. So here, I would write a statement here. In 2010, there were 7,056 banks. There we go. We have finished that word problem completely. questions? That wasn't so bad, was it? Now, I'm going to ask you again. When you're doing a word problem, should you be following these steps? Absolutely, to the T. Now, some of you already get it and you don't need all of this because you get it. That's perfectly fine. I ain't mad at you. I'm just saying, if you know that you're going to say, oh, I might follow the steps, just make sure we don't make any mistakes. All right, last one. Last one, and then we're done. What's the topic? Let's read and see if we understand the topic. It says the number of cell phone subscribers in the millions between 2001 and 2009 can be modeled by the function S of X. In this case, they chose to use S. Why S? Subscribers, okay, people that have cell phones. All righty. And S of X is equal to 21X plus 101.7, where X is the number of years after 1995. Okay, X is the number of years after 1995. Let's read the question. In what year does this model indicate that there were 311,700,000 subscribers? Now, do you understand the topic? I'm going to go back again. Do you understand every word in the word problem? Okay. Do you understand what a cell phone subscriber is? That means you got one, right? Okay, we all pay for it every month. We all got one. How many people are using cell phones? That's what we're asking. How many people in the millions use the cell phone? Is it proper for them to say millions? Yeah, because, I mean, we can't say a couple hundred. We can't say a couple thousand. Millions of people are using cell phones now. So it's proper for them to use the word millions. Now, look at the equation. Even though we're talking about millions, look at these numbers. That's 21, 101.7. These numbers are still, think in millions, even though they made them small, so we wouldn't have a whole bunch of zeros to deal with. We're going to come up with an answer. So let's say, make sure we can work with what we got. All right. Step one, what were we supposed to do? Read the problem. Did we read it? Do you understand it? Let me ask you a question about the last question. In what year does this model indicate? Are they asking you for an X value or a Y value? In what year? Okay, so let me write down what we got so y'all can help me out. All right, we read the problem. All righty, number two, we understood what the problem is talking about. I want to make sure again, in that my last question. In what year? Are they asking you for a year or a number of people that got cell phones? They want a year. A year will always be your input value. It will never be your output. Years usually will always be input or X values. They will not be output values in most cases. Okay, so they are asking you for a year. All right, we read the problem. What they give you? What's given? Okay, so number of years after when? After 1995. Did they give you a Y? Yes. What did they call it? Instead of calling it Y, what do they call it? S of X. So when you say Y, it's the same thing as S of X. Anytime they say S of X, P of X, F of X, W of X, whatever it is, it's still Y. It's still output. Okay? So remember, this is your input. Here is S of X, which is your, what's this talking about? What's the Y talking about? I know it's an equation, but what does it really mean? What does the Y really mean? What does the S of X really mean? Number of cell phone subscribers, the number of cell phone users. Cell phone subscribers, people who have cell phones. Okay? All right, did they give us an actual equation for that S of X? Yes, okay, so that Y, which is S of X, is equal to 21X plus 101.7. All righty? In the last question, were you given something else? A number. What is that number? Okay, they gave you how many subscribers? 311,700,000. Is that an X or a Y value? It's a Y. So they gave you a Y value. Alrighty. So they gave me a Y value. What's number 4? I'm supposed to do what? What am I asked to find?
Find the X.
Okay, I'm finding this. Let me rewrite this a little bit higher. 311,700,000 cell phone subscribers. Okay, and you said we are trying to find an X value, and I'm going to call this also, I'm going to put in parentheses, a year. We're looking for an X value for a year. We're looking for an X value for a particular year. Alrighty? In order to do that, do we have an equation? If you have an equation, should you be using it? Yes. If you have an equation, you're always going to plug in an X or a Y. You got to plug something into one of them. So, in this particular case, to find the X value for that particular year, I've got to plug in what? I'm going to plug in 311,700,000 in 4Y in the equation. Okay? What's number 5? Do the math. Now, I have one quick thing before you plug that in. That number's too big. How do you know it's too big and you can't plug in that number that big? Look at the rest of the equation. Do they have any numbers that's got that many zeros in it? No. So if they don't have the number in millions, you can't write yours as big as yours is. So can I convert it to, like they have their number, can I convert it to millions without putting the zeros in it? How do I convert that to millions? Just by using the word millions without putting all the zeros in it. How do I rewrite it? So here, let me ask you a question. If I say 21 million, how do I write 21 million without putting all those zeros? Y'all looking at me, 21 million. Okay? If I have 21 million with all the zeros and you want to rewrite it without the zeros, just use the word. Use the word where the zeros would be, you'd have the word millions. And that should say millions. So now with that in mind, how do I write 311,700,000 in words with that like I did here? So you got 311. Okay, so we're going to do 311. Now, I need something else because where does the million start? The million start right here. So I need a decimal right there. 311.7 million. If there's another number there, like we have that 7, you've got to put a decimal in front of that 7. How did you know to do that? Look at your equation. If they ain't got no big numbers, you can't use big numbers. So model that. And in the example in the homework, it would have shown you what they did. So now in the place of the Y, am I going to put all of the numbers with all the zeros? Or am I going to rewrite it and put in 311.7? Okay, so now I'm going to plug in, again, I'm going to put it in red. So rewrite this as 311.7 million. All right, now can I do the math? Yes, now I can do the math. So I'm going to put in the place of my Y, 311.7 is equal to my equation 21x plus 101.7. I need to get x by itself. What should I do to both sides? Subtract 101.7 from both sides, and I end up with these two canceling. Now I've got 21x on the right. When I subtract over here, I'm going to have 210 on the left. Divide both sides by 21. Divide both sides by 21. So x is equal to 10. Is that my final answer? No. Did they ask me for the actual x, or did they ask me for in what year? Okay, so x is the number of years when? number of years after 1995. So what should I do with that 10? Okay, 10 plus, let me scoot this up a little bit, 10 plus 1995, because this was years after 1995. And I end up with what year? 2005. And that answer is, in 2005, there were 311,700,000 cell phone subscribers. Done. You will have one just like that in the homework. Questions? That's it for 2.1. So the biggest part of what you learned in 2.1 at the beginning was how to solve and get x by itself. Once you learned how to solve and get x by itself, then we picked a word problem where you still had to go solve and get x by itself. And then it just applied to something in real life. That's it. All we learned to do was solve and get x by itself. So this is part of test 1. That's it. Nothing else gets into test 1. This is the last part of test 1. Okay? So I'm done. Everybody sign in on my sign-in sheet. I have my notebook I left in a different class. Did you sign in on the sign-in sheet? Make sure you sign in on the sign-in sheet. Let me stop this one.